The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to Tech Geek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by various industry experts to give you all a crisp insight of various domains. The topic of today's session is test systems, and in our panel today, we are having 4 guest speakers. Our first speaker is Mr. Dave Ranson. He is Managing Director at Moog India. Dave has guided the development of Moog India Technology Center, that is MITC, since 2009. Under his direction, MITC has established an aerospace qualification test laboratory which has achieved AS 9100 certification as a design center and proven itself as a center of innovation for key technologies that support aerospace, automotive, and industrial controls. With over 30 years of aerospace experience, Dave has led research, innovation, and new product development organization for 3 companies across US, UK, Brazil, and India. Dave has worked extensively in India since 2007 and moved to Bangalore in year 2010. Our second guest speaker is Mr. Mohan D. Krishna. He is section head at Moog India. Mohan, after completion of his graduation in mechanical engineering, had joined TISCO, Jamshedpur as a trainee and then served as a assistant system analyst at TAIO Jamshedpur for 4 years. Later he joined Aeronautical Development Agency Bangalore as a scientist. During this period, he was involved in designing, development of aircraft, hydraulic and fuel system components. He has also anchored indigenous design, development and qualification testing of flight control acquisition system for LCA Tejas aircrafts. Subsequently, in year 2008, he has joined Moog India Technology as Mechanical Engineer Manager, who was responsible for design engineering services to various commercial aircraft programs. Currently, he is heading Qualification Test Engineering section and responsible for qualification testing of flight critical servo actuators gearbox of Boeing 878, Dreamliner, Airbus A350 and commercial aircraft programs. Our third speaker is Mr. S. Gurudev. He is also section head at Moog India. S. Gurudev has served as a group director until December 2013 in Aeronautical Development Center, which is under DRDO, Bangalore, and was responsible for airborne embedded computers and ground-based real-time test system for integrated flight system control. He was also a key member and head of several technical review committees for reviewing, approval, and issue of system engineering design, development, test plan, and test report of various large systems in ADE and other establishments in DRDO and CSIR. He also contributed extensively from concept of operationalization, maintenance, inspection, and certificate stages of architecture, hardware, and software of several FCCs test systems, Ironbird for the LCA, and hardware in loop simulation system for UVAs. He was awarded as leader the highest national level DRDO team award for performance excellence in self-reliance in year 2001 for digital flight control system for LCA. Our fourth and last speaker is Mr. Satish. He is sales head at Moog India. Satish has started career at National Aerospace Laboratory as test engineer. He is having overall 24 years of experience in aerospace structural testing and simulation. Prior to joining Moog, he worked as a managing director heading the operation in India for FSC control system of Netherlands. He joined Moog since 2005 with the acquisition of FSC system control by Moog Incorporation. Currently, he is working as a sales head, test and simulation at Moog India Bangalore. So without any further delay, I introduce you to all our guest speakers. Over to you, gentlemen.
Thank you, Gaurav. This is Dave Ranson. Today we'll be talking about test systems for critical applications. Whether you're an experienced engineer or just starting your career, we hope that you will find today's discussion helpful. Test systems for critical applications are challenging because they bring together engineering disciplines to develop complex test systems that meet extreme demands of testing for critical systems in multiple domains: aerospace, defense, railways, automotive, civil structures, to name a few. Today we'll be talking about what it takes to be successful in testing for critical applications. At Moog, we found the following capabilities are critical to our success. In the system integration and testing realm, understanding system requirements and architecture is critical. The ability to field large-scale test systems and integrate them, and then to design test rigs and test consoles that go into those facilities is critical. Ultimately, being able to customize the systems for particular applications. Test data analysis, reports, certification, each of these disciplines are very important in an organization to be successful. These projects are often very large scale, and so disciplines like supply chain, logistics, project management become very critical to seeing successful implementation on time and in budget. We also find that training is critical to the success of a key installation. What does it take for an engineer to be successful in test systems? In your education, we recommend one thing: learn your core subjects. Understand the physics. We can teach you the rest. On the job, you'll need to learn specifics in your engineering discipline. If you're in electronics, understanding either analog board design or digital electronics can be very helpful. Instrumentation can be a great help in this realm. For system engineers, understanding control theory and how to manage requirements, all critical. But ultimately, in getting started in this domain, you need to learn the basics. All of this is ultimately for the goal leading to successful hardware and software integration and testing. I'd like to introduce you to my colleague, Satish Kadanur. 24 years of experience in this business. He can speak with authority and good knowledge on this subject. Satish, we've talked about why the testing and simulation is so important for critical systems. How do they fit in a typical product development cycle?
Thanks, Dave. Testing and simulation fits at two critical junctures of any product development cycle.
Sorry to interrupt you, gentlemen. Your voice is coming very low. Can you be a bit loud?
Yeah, sorry. Testing and simulation fits at two critical junctures of any product development cycle. One, before the launch of the product to verify the product performance, and second one for the final use of the product. The iterative cycle between design, simulation, and test will lead to the final product. And again, we use the simulation for training.
You make a good point, Satish. Thank you. The fact that you can use simulation to iterate the designs ultimately results in test systems that are optimized for the applications. That's a good point. Many applications use testing and simulation. Aircraft structural testing is, of course, a very important one for Moog. Tell us about the types of structural testing that are used in the aircraft industry. Maybe you could give us some examples.
Sure. Testing in aircraft industry is grouped into two segments. One is structural testing, and second one is component testing. For aircraft testing, we use for full-scale static testing, full-scale ultimate strength testing, full-scale fatigue testing, which is called assembly testing, and the component testing. And coming to the functional testing, it can be categorized as flight control system testing, fuel system testing, landing gear testing, cabin pressurization testing, onboard hydraulic system testing. And few of the examples for the structural testing, what you can see is one of the programs where Moog has worked with Joint Strike Fighter program for F-35 for a full-scale both static and fatigue test, which involves 536 channels of aero controller and 10,000 channels of data acquisition system. Coming to the next one, the component one, which is part of the wing fatigue test conducted at Airwest UK, incorporates about 34 channels of aerocontrollers and 500 channels of data acquisition. Coming to the functional test, it's again A380 landing gear system test. It is performed at Airbus UK.
Thanks, Satish. The size and complexity of these structural test systems is impressive, especially in person. But there are many other industries that use this same kind of technology. Maybe you can give us a quick overview for the benefit of the engineers who might be considering a career in testing and simulation.
Other market segments which involve the testing and simulation apart from ground vehicles and aerospace are energy, consumer goods, electronics, life sciences, and construction equipment. Testing in all these markets is primarily of two types. There is performance, which is functional durability and life cycle, and compliance, mainly for certification and homologation. And coming to the focus market for MOOC, we are currently mainly focusing on ground vehicles, which includes car, train, buses, trucks, railways, and military battle tanks. And coming to the aerospace, both commercial aircraft and military aircraft. Currently, MOOC is involved in testing of stages or LCA, light combat aircraft, full structural tests which is being carried out at HAL Bangalore. Yep.
Excellent. Thank you, Satish. So testing and simulation offer a broad range of opportunities for engineers from many disciplines. Before we dive into the details of the testing and simulation, let's look at the key steps in the overall development cycle and how testing and simulation fit in. This figure describes the basic steps in a large testing and simulation development program, starting with understanding what tests need to be run, the requirements, and then selecting hardware. A company like Moog brings a lot of previously designed, established equipment to bear, controllers as well. But ultimately, there are many times when there need to be bespoke configurations for a particular application. And one of those areas in particular is input and output. Selection of the I/O is critical to the success or failure of a program like this. Satish showed you a figure of the F-35, which had over 600 channels of input and output. And so the amount of data that's processed in these kind of systems is significant. But it's not good enough to just have a system in place. It has to be accurate. And so there's a key calibration activity, and then very important safety evaluation, making sure that the test operation will be safe for equipment, but mostly for people. Then the practical part of tuning the controllers, making sure the system actually behaves as intended prior to actually operating the test. Depending on the domain, there are different spectrums that are required. For the aircraft domain, there'll be a mission profile that actually defines what kind of testing is required. For the automotive industry, there'll be actually country-specific road profiles that are used to determine what kind of aggressive testing is done on the system and ultimately operating the test. All of this, based on simulation and a group of experienced people, allow us to optimize the systems. I'd like to ask my colleague, Mr. Gurudev, to talk a little bit more about the details of what goes into it. Gurudev has been in the business for a number of years, and as mentioned earlier, held significant positions within ADE. His experience has proven to be very, very important in our success. Gurudev, we've talked about the major domains and the complex systems. We briefly touched on the product development workflow here, but since many of these applications are state-of-the-art, often one of a kind. They often require unique test systems solutions. Let's talk about the range of technologies and the challenges involved in providing the right test system for a particular application. Flight control systems are particularly challenging.
Thank you, Dave. You have touched a lot of topics, and coming to the focus of the test solutions being developed in MOOC, it's primarily meant for flight control system, both at the component level and at the subsystem level, and various other computer parts of the flight control system. Now, you could see in this slide that there's a classification of the test system. We design custom-built solutions for carrying out functional tests, which are basically helpful to the designers of those target LRUs, that's for the actuation systems. We finally develop systems for carrying out acceptance tests, which will be deployed in the factory. Before that, there's a policy. And finally, hello? Can you hear me? Okay. And finally, we also build test systems for carrying out endurance wind fatigue, which will really prove that the flight control system components can last the life of the aircraft. As you can see, the flight control system actually consists of primary, secondary, which is also called as high lift, and actuation systems. MOOC is also specialized in developing cockpit systems, and nowadays they are getting into even the flight control computer LRUs, which are focused on the actuation systems specifically. Of course, we are into all major programs in the world. You can see Airbus, Boeing, Command.
Sorry to interrupt you guys again. Can you bit loud, please?
Sure, I can. And finally, challenges which Mr. Dave mentioned.
Yeah, this is perfectly fine.
Flight control system. These are meant for flight control system. And flight control system in an aircraft is one of the more, or rather the most safety critical item. And the test systems designed for them are really as challenging as what we designed for the airborne system. First of all, the test systems themselves have to be very reliable, because any downtime in testing affects the certification of the flight control system in the ground. So they should be maintainable, because these test systems have to last for nearly 20 years, 25 years, because once the components are manufactured in the factory, they have to last long. And of course, like any test system, it should have reproducibility and repeatability 100%. Of course, cost is a very big factor. And coming to the unique features of the test systems, I would say that they're all meant for real-time testing. A lot of other activities go on, data archiving of huge amount of data. And as you are aware, all these actuators have to be tested under actual flying conditions. So they have to be loaded as if they are actually loaded in the aircraft flying conditions. So we have a lot of control loops, and we have to do correlation. So these are some of the challenges which we face in designing, which no industry commercial off-the-shelf system can provide to us. So I think that answers the challenges and the
Great, thank you.
unique features.
If you could also talk a little bit about some of the test systems that we've been discussing. It's important to remember that one of the most critical parts of testing these systems are the processes and the people who configure the test systems.
Okay, so I'm showing here some of the figures of the test rigs. You can see this is meant for the Airbus 350. And you can see this is meant for the primary flight controls, that's the servo controls, actuators, the EHA and EBHA. So it shows how a test system is not just a test controller with software. It has to have a mechanical stand, hydraulics, and a loading system as part of the stand. And all these have to be controlled by electronics and in turn by computer. And you see it's a multidisciplinary, as Dave has been mentioning, that it's totally a multidisciplinary approach. Yes. And of course, I'm showing you one more slide which shows the testing system for a high lift, where it's not servo controlled really, they're all gearboxes. And this, the next one. This shows a typical console which is used to operate the entire mechanical stand with the hydraulics and have built-in safety features, collect data, and archive it and send it in real time or out online to the network access storage for post data processing.
So I'd like to have us talk just a little bit about what's next. Some of the engineers in the audience may be interested in, what are the things that are on your mind as far as the next generation of test equipment? You can go 2 slides forward, one more slide forward. Right, there you go.
Actually, we have been concerned a lot with manufacturing these test systems for our internal use, and cost is a very big factor, and obsolescence is another big factor. So we have selected one of our in-house MOVES microcontrollers, or the PLCs, and that's called a MC600. Using this, we have been very successful in stepping to the next generation of test controllers, and this will be very useful for supporting all our aircraft testing programs for the next 20 to 25 years. This is one of the big achievements to bring down costs and have high performance all together. So we will be facing less and less obsolescence issues.
Great. Thank you, Gurdev. Most of our conversation is focused on systems, but it's important to remember that it's not just systems, it's the people and the processes that allow us to be successful. I'd like to introduce my colleague Krishna Mohan, who's head of our qualification lab here in Bangalore. He and his staff recently completed safety of flight testing on 2 major aircraft programs, the Boeing 787 and the Airbus A350. Mohan, tell us about the types of testing that are required for aircraft flight control certification.
Thank you, Dave. Looking at the aircraft flight control certification aspect, there are many standards and guidelines that are provided to us, such as Federal Aviation Administration. They provide some guidelines. European Aviation Safety Agency, EASA, they have a set of guidelines. And we also have Aerospace Recommended Practices, we call ARP. As you rightly mentioned, Dave, we have successfully completed safety of flight testing of many major LRUs for commercial aircraft program. As my colleague Gurudev mentioned, we have these test systems which you are seeing on the right side, the endurance test stand, where we mount the actuator and they carry out the testing. It is a typical load profile, how the aircraft flies. We use the same load profile on the ground and ensure that the actuator is subjected to those load conditions, and the endurance is carried out, test is carried out. We also do a fatigue, impulse, low temperature, maximum up to minus 54 degrees centigrade, and a high temperature almost like plus 135 degrees centigrade. These are the tests carried out as per the guidelines which I have already mentioned. You can see the picture there below. The actuator is subjected to minus 54 degrees environmental testing. The next slide shows some of the DO 160 environmental tests. These are the guidelines which provide, these standards provide the environmental test guidelines. And as per that, we carry out vibration, humidity, EMI/MC, salt, fog, icing, thermal shock, salt, and sand and dust. These are the tests, are already provided to us. And you can see the picture here, the vibration test being carried out on one of the LRUs, gearbox, and the salt fog, which is being carried out at the lower end of the screen. You can see the unit is positioned in a salt fog chamber.
And you listed quite a few requirements and standards that apply to the qualification testing, but there are many unique requirements for each aircraft. Tell us how you and your team deal with such a wide variety of requirements for aircraft flight control certification.
Thanks, Dave. Again, as the customer comes with varieties of requirements, what we do is we develop our own internal processes. We are very process-oriented, where we are very careful of the safety of the unit under test. The personnel who is testing the units, they need to be safe. As the test is happening, we need to make sure that the health of the unit is monitored over the entire test range. As the test is being carried out, a lot of data is being generated, which is acquired through test consoles, which my colleague Gurudev already has shown. The entire data needs to be managed properly. We need to analyze each of those data which is collected, make sure that the every channel is analyzed, it's meeting the requirements, and a report is generated at the end and submitted to the customer. We also have to have a very high level of configuration control to make sure that whatever we have tested is traced back with the right version of software, right version of the test load cases, etc. So these are all the processes which we have developed internally to make sure that we are testing the hardware to meet the aircraft standards. We also need to have a very good process to make sure that the process what we follow are AS910 certified or a SEMILAC certification, which gives us a lot of confidence that whatever we test at the site are accurate, and the hardware which we supply to the customer is safe to fly.
Thank you, Mohan. We're at the point now where we'd like to open the discussion to answer questions from online participants. As we receive your questions, one of our team will address your question. If you can open up the question box.
I request all my participants, if they have any question, they can post those questions to us. We will ask our guest speaker to answer them.
We're just opening up the screen here to.
So we are waiting for the question. If we get any question from our participant, definitely we are going to forward to you guys.
Perfect. Perfect. One question we often get from engineers that are early in their career is, how do they prepare? How do I prepare? We attempted to touch upon that just briefly earlier in the presentation, but I can't emphasize enough how important it is not to get too quickly into specialization. One of the keys to success in this realm is understanding the basics very thoroughly so that you can make good decisions when unexpected things happen. And so what we look for in a successful candidate who would join Moog would be someone who has a good understanding of their fundamentals and also can quickly understand new concepts. And from there, we can help the young engineer learn what he needs to know to be very successful in his career.
So there is first question for you guys. Can you see the question, Krishna?
Yeah, let's see. Okay, so what we should do is let's read the question aloud, and then one of the team will answer.
Okay, the question is, what kind of preparation would help for aerospace domain specialists, Evo 178B life cycle and HSI and SI testing?
So let me restate the question. What I think the participant is asking is, how do I prepare for working specifically with DO-178, which would tell us he's thinking in software, and he's talking about HSI, hardware-software integration, and SI, which would be software integration. We'll ask our colleague Gurudev if you could just talk to that a little bit.
Actually, the first question is mostly about software. So although it's not part of the mainstream topic here, we will give you an answer. DO-178B is the current standard, as you are all aware, for safety critical systems. And there are very few companies in the country which are which are giving any kind of training So you have to learn it on the job. Of course, you have to join the right company as an intern and work your way through. So before you are allowed to develop code for the alternate standards. Of course, there are a lot of industry standard tools available now to simplify the process and prevent novices and freshers making mistakes. So most of it is on training, is on the job, and you will get to know as you grow the subtleties of developing code for 0178. Of course, hardware software integration, you have to learn it with that specific system. If you're developing for a particular flight control computer, before that you will have to do design of the code, you'll have to test it with CFU, CFC testing, and afterwards, if you are not still in design or testing, and you are assigned the role of integration, you'll have to get into integration. But at that time, you should be very strong in the hardware also. The hardware of computer, the analog and input discrete channels, the communication protocols. So hardware software integration brings a person who is basically an electronic with the flair for software without forgetting the hardware. So this combination, who are all strong in all these three: hardware, software, test plans, procedures. So generally, HSI people are more senior, and it's always required for a person to start from true software, from an electronics background, and then migrate to hardware software. I hope that answers your question.
I'd like to have our colleague Satish take us back to slide number 9. And there are several applications that, for interest of time, we moved quickly by. And so what we'll do is ask him to just describe a couple of the things on that.
Number 9.
Perfect. So we're on slide that talks about aerospace testing. There are several large structures here. Maybe you can tell us about those, Satish.
On bottom most, what you see is full-scale fatigue testing of a fighter aircraft F-16 done by Goa Aerospace in Switzerland. F-16 aircraft needs to be retested by Swiss Air Force for having modified for short takeoff and landing. The fuselage has been strengthened with the titanium bulkheads. That is one of the reasons why Swiss aircraft tested with F-16 in-house in Ruag Aerospace, which involves the full-scale testing and static testing, and also the ultimate testing of the aircraft, which was done in a quick period of 24 months. The entire life cycle of the aircraft has been completed successfully. And what you see on the right-hand side top is a full wing, is a composite glass fiber wing being tested at Airbus UK, and which involves a wing length of more than 12 meters, and it utilizes a hydraulic system to test the wing. On the bottom most, what you see is the testing simulating the landing gear equipment. Yep.
Right. Thank you, Satish.
Thank you.
There was another application on the next page I'd like to talk about. We've talked about the landing gear testing. There's also
what you see on bottom most left-hand corner is Ironbird test rig, which involves the testing of all flight control systems, which are simulated on ground before the first flight. And similarly, there are certain portions of the components that are being tested on the right-hand side, and again on the bottom of the right-hand side is the landing gear, main landing gear being tested for its life cycles and endurance. Thank you, Dave.
Great. Thank you, Satish. Is there another question up there you wanted to address, gentlemen?
Yeah, there's something like usability test.
Yeah, there's two parts to this, Dave. If I'm correct, the usability testing is what the customer is looking for, what type of testing he is asking the user to do it. That's one type. It could be a software, DO 178B type of testing, or the hardware testing. So the software side, probably I'll leave it to my colleague Gurudev. On the hardware side, some of the specific requirements come to us, something like, hey, can you do a fatigue testing for this load? Which are never defined by any standards. So they are specific to a customer requirement. Say Boeing has a different type of requirements, Airbus would call for a different requirements. So if the question is towards the hardware side, yes, we do, where we have an interaction with the customer, we understand the requirement, we prepare a statement of work, we define the input and output for each of those requirements, and then carry out the test, for which we may have to define a test system and its configuration around to make sure that we are meeting those requirements, which is typically complex, because the users would be varying their requirements as they understand. So that's on the hardware side. Probably, Gurudev, how about the software? How does it go?
Well, it's like this. I think this term usability testing is come mostly for the software part, and although we don't do it here, again, I like to answer the gentleman who asked this question. Before a software is formally released, the cycle times of software development and release is so long. I think if you are referring to some kind of a beta testing by deploy it on known customers who will participate in the testing, that's one way we can categorize that kind of testing as usability testing. So before it's formally rolled out, a lot of testing takes place with a large spectrum of users who are willing to participate in such tests. In our context, we don't do any usability testing because these tests are really going to be, cannot be done by the pilots in the aircraft. He has to be assured that what he's flying is already tested, finished. At the most, probably during the, before the aircraft is commercially released, there will be flight testing. So during those flight testing, you could perhaps categorize the testing which goes on in air as a kind of usability testing of the actual system. This could be the way in which we interpret for our domain.
Great. Thank you, Gurudev. Looks like there's another question has come in.
Yeah, I talked about how does the system testing differ from system integration testing. Probably, Gurudev?
Yeah, I can pitch in.
Perfect.
See, again, let me tell you in our domain, when we say system testing, it could mean a lot of things which are simulated. If I got 10 LRUs, I can do system testing without the real units. I can simulate the behavior of many of these LRUs and do testing without seeing any real LRUs. But it's working as a whole system. When I say system integration, I'll be plugging in a lot of real LRUs in incremental fashion. So it will be a mix of simulated and real LRUs. So in our context, we do distinguish between system testing and system integration testing.
Thank you, Gurudev. That's a good point. In fact, you pointed out another real strength of our simulation capability in the industry. We talked about using that to optimize the designs of large-scale test systems, but you also pointed out the fact that it allows us to test system performance without having all of the system components in place, because we can simulate portions of the system digitally. That's very helpful. If there are no other questions, let's go to the last slide. I'd like to just wrap things up. Let's just reflect back a second on what we've covered. We talked about testing for critical applications and what it takes to succeed. We talked about using state-of-the-art systems and equipment, definitely important. We've talked about robust processes and process discipline, absolutely imperative. We've talked about analysis and simulation and how that allows us to optimize systems or to test entire system configurations without all of the parts present. But most important, I think we should come back to one final thing. Most important in all of this is capable people who understand the system-level interactions in these systems. And that's where you come in. With engineers who understand the fundamentals and can work collaboratively across disciplines are the ones who will be most successful in this kind of arena. We hope you found today's discussion helpful. If you have other questions, feel free to contact us. Our website is moog.co.in, or you can follow me at LinkedIn or my Twitter account at Dave Ransom.
Yeah, sorry to interrupt you, Dave. Recently we got one more question. Can you please check that question also?
Be happy to. That's why we're here. So.
Yeah. Thank you.
Can you come down?
Mohan, are you able to see the question?
Yeah. The question is circuit cracking observed during full scale in laboratory. How does it compare with cracks developed in reality during real life?
Oh, there's a philosopher among us. This is a topic that's been an ongoing discussion for not just years but decades. And as we, as an industry, get better and better at understanding the micromechanics of crack formation and propagation, we are finding better and better ways to calibrate and correlate the testing results with actual field performance. Today, we can say that we're much more accurate. We're much more we're able to predict the life with much greater certainty than we were a decade ago. But this is actually a process of ongoing understanding, simulating the microstructure and that behavior at that level, as well as the macro behavior under operational service compared to the extreme testing that we conduct. And in fact, that gets to the heart of the matter, why we do this kind of testing. The severe environments, the severe conditions are meant to over-test these applications to compensate for the possibility of microscopic flaws that can develop into cracks. I hope that's helped you. Well, Gaurav, it looks like that's the last question we have. We certainly would welcome anyone contacting us at
Sure.
co.in. Thanks for your time.
Yes, I'm really thankful to our all guest speaker for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on techgeek.com by tomorrow. Thank you all. Thank you, Moog team.
Thank you.
Thank you, Gaurav. Thank you, Gaurav.
Thank you.
See you all in the future. Have a good day. Have a nice day. Thank you.
Thank you. Bye-bye.